The next question now will simply say to you, calculate the total resistance of the circuit. So in order for you to calculate the total resistance of the circuit, what a total resistance of the circuit, this is what you should understand, guys. So all of these things, this one, all this and all those one, those, they are instruments that we use. This, it is the instrument which measure a voltage, this one. And this one, it is the instrument that measure what? A current. So what you will do there, you can remove them, all those instruments, so that your circuit will become like this, so that you can only focus on the resistors. So now it's easy for you now to calculate what a total resistance now, because these two things there, you can notice that those two resistors, they are in parallel. Those one they are in parallel, meaning that you will start by combining them together. Then this one you can name it as resistor 1, this is resistor 2, this one is resistor 3. Do you see? Yeah. So this thing there, we can calculate them there, meaning there, this is how you will get them. We'll just say resistor parallel, which is 1 over R1 plus 1 over R2. Then you substitute there, which is 1 over 9 plus 1 over what? 18, which is Rp. Then you use your calculator, start by simplifying all of the stuff there. So you can punch that stuff on a calculator, meaning that it's 9 plus over 19. So this is what you get there, which is 1 over 6. Meaning that here I'll get 1 over what? Over 6 and Rp there. So again, now what you can do now is for you now to remove this fraction. For you to remove this fraction, you can put even in that -1 here, -1. That -1, guys, will flip this fraction. Then that fraction will become Rp. But here you can even use your calculator. All of this thing, you can press it on your calculator, so that you can get a final answer, 1 over 6 minus that. So meaning there you'll just get 6, meaning this thing is 6 ohm. Or if you feel this method it's hard, you can even do a cross multiply there. Saying this here, you can even do your cross multiply. This will multiply here, that will multiply there. These will multiply each other, meaning that this multiply that one, it's Rp. That will multiply 1 multiplied by 6, which is Rp. It's equal to 6 ohm. Yeah. So it simply says now, when you combine these two resistors, which are in parallel, when you combine them, your circuit now will just become like 1, 2. So here it will just be like this, that circuit, which is 2. And here it's your resistor, which is in parallel, and that resistor is 6 ohm. So here we say that that one is A3. So this is how your circuit now will become now. That circuit will just become like this there, after you have combined these two resistors which are in parallel. Then your circuit now will become like this. Meaning now this circuit can now, if you can notice, these two resistors now, they are in series now. For you to calculate resistors which are in series, this is how you will get them. You'll just say series circuit, you just say R3 plus Rp. Meaning this thing, it will just give you this and that. Then you use your calculator. 2 plus 6 there is just 8 ohm. Yeah. Meaning this thing there, it's also your what? Your total resistor there. Meaning now your total resistor will be 8 ohm. Because that circuit now, when you simplify it, that circuit now, as a final answer, that circuit will become like this there. Okay, it's a battery, so that circuit there, it will be just be 8 ohm which is total resistor. Do you see? Yeah. So in order for you to calculate what a total resistance, the first thing that you should do is for you to remove all the measurements there. Only focus on what? On the resistors. Then you can start where you see parallel resistors. Then you simplify them by using this equation. This is how you calculate resistors which are parallel. You use this equation there. But now when you are calculating resistors which are in series, this is the equation that you will use. Then I'll put NP there. Do you see? Yeah. So meaning now as your final answer, a circuit now will become like this, which is this. It is its total resistance of the circuit there. This one. So now the next question will say now calculate the reading on voltmeter V1, which is here. They need you to calculate this voltage there. So for you to get that voltage guys, it is also what? A total voltage there, because it reads a what? A battery there. That voltage is also what? A total voltage, because it reads a battery there. Then if you can try to understand this thing from here, we know that the current the current which is delivered by the battery, it's 6 amperes there. That is the current that we know. Then it comes here, that is the current that is delivered by the battery, meaning that current is also what? A total current, by the way. So meaning we know that current is delivered by the battery. Then it move, then it separate here. It separated, come, then it get combined, then it move here. Do you see? So we know that current that is delivered by the battery. We know that current there. So then that current there, it is delivered by the battery. That current, it is delivered by the battery. Then it go back. Then if we can only focus on this one there, on this circuit, that current, we know that current there, the one that is delivered by the battery, that current there, it's 6 amperes. And that current, I told you that current, it's a what? It's a total current. And at the same time here we got a what? A total resistance. But what we are looking for, we are looking at what? V1, which is that V1, it reads a battery there, meaning that V1, it will be also what? A total voltage there. So if you got a total resistance 8 ohm and you got a what? A total current 6 amperes, but you are looking at what? A total voltage, still here you will use what? Ohm's equation. So meaning now you can substitute 8 there, and that one is the one that you are looking for. Then the current there, it's 6. So here we got a what? A fraction. Here we can put invisible one, so that we will have a fraction and a fraction. Then we can do cross multiply. These two, they will multiply each other. Those two, they will multiply each other. Meaning that V multiplied by 1, you will still get V there. And 8 will multiply by 6, meaning now your final answer, press that thing, 6 multiplied by this thing. This is what you get there, which is 48 volt. And that 48 volt, by the way, it is the what? It is the total current, which is also the same as what? As V1. So it means that our V1 is 48 there. Do you see? Yeah.